Hey everybody, just a quick note before we begin. This one was very much a spur-of-the-moment decision, so I didn't plan out the information as well as I will in the future, and I apologize for the crappy editing and sound quality and all of that. This is my first video, and I'm kind of learning as I go, but I will be taking suggestions for more topics to do, and thanks for watching. Alright everybody, hello and welcome to the sort of premiere episode of Drunk Science. Hi, I'm Theeq, and I'm kind of drunk, and I'm a scientist, hence the name of the show. So today our subject is going to be going above and beyond the periodic table. So for those of you who didn't take a high school chemistry class or are unaware of the chemical world that we live in, the periodic table is organized by chemical properties, how it reacts with certain things, how it behaves, that kind of stuff. What we're talking about today is we're going to be talking about specifically aluminum and indium. Now aluminum and indium are pretty cool for two completely different reasons that kind of go beyond what the periodic table is talking about. Let's start with aluminum. Aluminum is a good friend of ours. It's refined from bauxite. It used to be the most valuable metal in the world. The tip of the Washington Monument is actually made out of aluminum. It was a way of showing how awesome America is, because at the time aluminum was super expensive. They thought about making it out of gold, but look up the history yourself. But there's this weird phenomenon where groups of 13 to approximately 100 different aluminum atoms can form together in a compound that scientists kind of refer to as jellium. Chemists aren't exactly known for their creativity. But so this jellium, you have 13 to 100 different aluminum atoms kind of coming together in a polyhedron, so a three-dimensional structure, but it behaves like one giant atom of something else. If 13 different aluminum atoms come together in this specific way, they behave kind of like a bromine atom, just a single bromine atom, despite the fact that it's, I don't know, 6 to 10 times the size of a bromine atom. Once you get that small, the physics gets a little weird, and I'm not the best at judging it. But all of the atoms kind of get smushed together, and the electrons get shared by all of the different atoms, and they kind of whirl around and go smoosh, 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 because that's the sound electrons make. They go smoosh, smoosh, smoosh. Little known fact. Science. It's a thing. They move to the outside, and when you have 13 of them, usually the configuration is you have 17 electrons kind of going on the outside of that polyhedral structure. So it behaves like a halogen. Halogen being group 7A with the 7 valence electrons, super reactive, and where we find friends like bromine. Bromine. It's a wonderful thing for reactions. Don't let it get on you. It hurts. Me. But so this whole jellium thing, you can get aluminum acting like bromine. It can act like calcium that you find in bones and other biological structures. It's kind of bizarre, but that alone isn't really above and beyond the periodic table. You think? Maybe? Yes, no? Indium is a really interesting element because electrons can pass through it pretty freely, but not freely enough to escape. Physicists will put together a series of insulators and indium and metal and blah 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 blah, and it will form what's called a quantum dot, where electrons get smushed into this film of indium atoms, and they move around like these giant orbitals. You think of orbitals in a single atom. Well, this is kind of orbitals over multiple atoms at the same time. Science. It's a thing. So these atoms with their giant orbitals can do a lot of weird things that there's no really good analog for in the periodic table as we know it. But they also operate within a fairly two-dimensional realm. So some people call them pancake atoms. And these pancake atoms, well, they're pretty unique. They're so unique that we can't exactly put them into our current periodic table. And so we might have to expand it into like a third dimension. You know, the periodic table going into depth. It's weird. You don't normally think about that. Fun fact, though, the current periodic table that we think of, like the one that's published in every high school chemistry textbook that you will probably ever see, that was developed by Glenn Seaborg between the 30s and the 60s of the 20th century. And it worked so well just as far as patterns and things like that, that more or less became the standard. But these pancake atoms, because they don't really behave in a way that we're familiar with, we're not really sure what to do with them. Although one potential use for them is in quantum computing, because we can manipulate those electrons and it's a lot faster than using integrated circuits. Fun fact, number 2, I believe, integrated circuits were originally made out of germanium, not silicon. And germanium works way better. In fact, there's a lot of transistors that are made with germanium doping. However, silicon is a lot more resistant to heat, and it's a lot more resilient, just in general, and a lot less temperamental. Sorry, but I guess we ended up with silicon. So I will be producing more of these, hopefully, in the future. I think Mr. Jack Daniels might have a whole lot to say about that. But I look forward to hearing what you say about that. Catch you guys later. Bye.